Okay, section 5.5 is solving right triangles using right triangle trig. We've talked about the right triangle, or we've talked about the trig functions, sine, cosine, tangent, cotangent, cosecant, and secant. We're going to use those to solve a right triangle. And what do we mean by solve the right triangle? It means that we need to find every single side and every single angle. All right, so first off, we got to look at what they're giving us, all right? And then from that, we can find everything we need. One thing you should remember from geometry is that in a triangle, we have 180 degrees in this triangle. Your angles are going to add up to be 180. So if I have a 90 degree and I have 52 over here, obviously I can figure out what my angle measure of this angle is right here very easily. Or we know that since this is 90 degrees, these two angles have to add up to be 90. So what I can do, either I can go 90 plus 52 and subtract from 180, or I could go 90 minus 52, and that'll give me the other angle as well. And that is going to be 38. Okay, so we have our angle measures. Now we need to find our side lengths, all right? And I'm gonna do them using trig, and then I'll talk about some other shortcuts that you can do. But this first one here, I'm gonna either angle, it doesn't matter. I'm gonna pick an angle. Say I'm gonna pick this angle 38 right here, all right? And so, say I want to solve for b. Well, b is opposite of 38, all right? So I need to find a trig function for the angle of 38, all right? And I need it for it to deal with the opposite side. So b is my opposite side. I'm given the adjacent side. So what deals with opposite all over adjacent? That is tangent. And then to solve for b, we're going to multiply by 12. So 12 times the tangent of 38. And we can get our answer very easily. So what I'm going to do is I'm going to go over here to my calculator right here. And I think this is in degrees. That's one thing you have to check on your calculator. No, it's in radians. Good thing I checked. Okay, you got to make sure whether it's in radians or degrees. All right. So I'm going to type in 12 times the tangent of 38, and this will give us our side length. So our side length is 9.3. It said round to the nearest tenth, so 9.4. So B is 9.4. All right. So from that now, we can find C. We have two options. I'm going to go ahead and use trig, but again, you have an option of the Pythagorean theorem. 9.4 squared plus 12 squared equals C squared. I'm going to go ahead and use trig. I'm going to use the angle 38 as well. Now what I'm going to do though, 9.4 is a rounded measure, so I don't want to use 9.4 when I go to find this side length, just because if you've ever heard of the butterfly effect, if you change something small in the past, it can have a very big change in the future. Well, that's kind of the same thing when you round a number. So when we made that number just equal 9.4 instead of that huge decimal it had, that can have a really big effect on the length of C. So what I'm going to do is I'm not going to use 9.4 for that. So now I want to find C. C is my hypotenuse, and I know for a fact that 12 is that's the actual number is 12 because it was given to us. So I don't know. I'm just going to pick the angle 38. Again, you could pick 52 if you wanted to. But I'm going to use the angle 38, and I know that 12 is the adjacent side. I'm looking for the hypotenuse. What deals with adjacent hypotenuse? Well, that is cosine. So the cosine of 38 degrees is going to equal my adjacent side, 12, all over my hypotenuse, which is C. All right, now we got to solve for C. To solve for C, multiply both sides by C. And then in order to get, so now I have C cosine 38. In order to get C by itself, I'm going to divide by the cosine of 38. Remember that cosine of 38 is just a number, so don't let that throw you off. Treat it just like it's a number, just like this is like 5C or something like that. Okay, so in order to get my answer, I'm going to go to my calculator and go 12 divided by the cosine of 38. Make sure my calculator is in degrees. I know it is because I did it earlier. So 12 divided by the cosine of 38. And my hypotenuse is 15.2. So C is 15.2. Okay, So that's all there is to solving a right triangle. Make sure you find each angle and each side length. And remember that kind of the butterfly effect, if you don't try not to use a rounded angle or a rounded side length if at all possible. Okay, so now it says in RST, find the measure of R to the nearest degree. So now we're going to go through how can we solve for an angle? The last triangle, we basically just solve for, well, one angle, which is really easy, and then we solve for two sides. Well, now we're going to solve for one angle given two sides. So we want to find this measure R, okay? So, and obviously this is a right triangle right here. I don't have my right angle markers, but this is a right triangle, and I want to find this angle R. Well, I am giving the opposite side. I'm given the opposite side, and I'm also given the hypotenuse. So we want to figure out, well, what trig function deals with opposite and hypotenuse, and if we write our SOHCAHTOA, we know that the sine of the angle, let's just call it x or theta or alpha, whatever you want to call it, equals, it should equal this ratio, 10 all over 12. All right. Then in order to solve for this, this x, we got to undo sine. We got to do the inverse of sine. When we have a problem like 2x equals 4, we do the inverse of multiplication, which means to divide by 2 or multiply by 1/2. We do the inverse, all right? So what we need to do in order to solve for this x is we need to do the inverse of sine in order to get x by itself. So if we do the sine inverse of both sides, we're just left over with x on this side because it cancels out these signs. And in this case, we'll do the sine inverse of 10 all over 12. So what I have now is x is going to equal the sine inverse of 10 over 12. And you notice on your calculator, a lot of on your calculators, you have to hit the second button. Mine's really nice and it's just right here. And so a lot of you guys will have to hit the second button and then the sign on your calculator. So I'm just going to type in the sine inverse of 10 divided by 12. Anytime we're looking for an angle, we are going to use a sine inverse or the cosine inverse or the tangent. We're going to use the inverse button when we're looking for an angle. When we're looking for side lengths, we're going to be using just the sine, cosine, and tangent. All right. So this -1 up here means that it's the inverse. If I hit enter here, that tells me that it's 56.4 degrees. So the angle R is 56.4 degrees. And then from that, we can figure out the rest of the triangle as well. Okay. And in this last one, find the values of the 6 trigonomic functions for alpha here. We've kind of gone through this and done this before, but our 6 trig functions are sine of alpha, cosine of the angle alpha, tangent of alpha, and then we have what goes with sine is cosecant of alpha, secant of alpha, and cotangent of alpha. And we know if we want to find these, sine is opposite all over hypotenuse, so this would be opposite of alpha is 8 over 17. And then we know that the cosecant is just a reciprocal of that, so that is 17 over 8. Cosine A, or alpha, cosine is adjacent all over hypotenuse, so 15 all over 17. So that means the secant is 17 all over 15. And tangent of A would be opposite over adjacent, 8 over 15. And the cotangent then would be 15 all over 8. And then if we wanted to find alpha's angle measure, each one of these, if we did the sine inverse of 8/17 or the cosine inverse of 17 over 8, we'll get the same angle measure for each one of these. It will not matter which one we do. It does not matter. Now, your calculators probably don't have a cosecant inverse button. So what you can do is if you get presented with the fact that you needed to use cosecant, if you knew that the cosecant of alpha was 17 over 8, if you wanted to figure that what that was in your calculator, since you don't have the cosecant inverse button, change this cosecant into sine. And in order to do that, all you need to do is flip this guy as well. So that's a question that comes up quite often. Well, how do I find the cosecant of this fraction here? Well, change it, flip it around so you can use the sine instead. I believe that's all I have for you. I hope this helps. We'll see you in class.